Okay, so very first problem of the test is just me verifying that this is a solution to this differential equation right here. Okay, this problem's pretty straightforward. Okay, so if I took this function and I wanted to investigate dy dx plus now 7 secant squared x now multiplied by y, okay, that would be e to the negative 7 tangent of x. Now we have to obey the chain rule on this. We need to take the derivative of the tangent. And so that would be negative 7 secant squared x. All right? And then we have plus 7 secant squared x. And then multiplied by our y, which is e to the negative 7 tangent of x. That I kind of ran out of room on that one. All right, so we have negative 7 secant squared e to 7x and positive 7, so it does in fact equal 0, and we get a big check mark. Okay, that was a little bit short for just one video, so let's go ahead and let's do problem 2 as well. Okay, so problem 2 says find an explicit solution to the initial value problem through separation of variables. Okay, so we have dy dx, now 2x y squared is going to equal 0. And we have a condition, boundary condition, that y of 1 is going to equal 2. Right? So we need to do this through separation of variables. So what I'm going to do is I'm going to take this component right here, I'm just going to move it to the other side. And so now I want to separate the variables, so I need to get all the y's on the dy and all the x's on the dx. So if I divide by y squared, dy, this is going to be negative 2x dx, okay? And then we can integrate this thing. Okay. Now the integral of 1 divided by y squared, okay? That's sitting at negative 2, so it has to go up to negative 1 and divide by that. Negative 1 divided by y is going to equal, this is going to be negative x squared plus c. Now let's call this C1. Okay. The only reason I'm calling it C1 is that everybody's got a negative on it, and so I'm just going to multiply everybody by a negative 1. Okay. So we have 1 divided by y is going to equal, let's say, just x squared plus c. That's the only reason I wrote a C1 on there, because it's, I mean, you could write negative C1, but let's change it to a different C. All right. So y is going to equal 1 divided by x squared plus c. Okay. So now that we're at this part of the problem, we need to use our boundary condition that y of 1 is going to equal 2. Okay? That means that 2 is going to equal 1 divided by 1 squared plus c. All right? So if we move this over to this side, that's going to be the 2 plus 2c is going to equal 1. Well, if we subtract 2 from that, we're going to get that c is going to equal now negative 1 divided by 2. So I'm taking a couple extra steps right there. But what am I really doing on this problem? I'm subtracting 2 to the other side, and then I'm just dividing by that 2 right there. So that's where I'm getting the -1 and the 2 on bottom. So the explicit solution to this problem is y is going to equal 1, still on the screen, divided by minus 1/2. That is the explicit solution to this initial value problem, or boundary value problem, I should say boundary.